Okay, good afternoon, friends. So, we will discuss the next method of site exploration, that is subsurface soundings. In brief, I can explain that. Let us say this is the ground level. Here, the soil is there. Okay, so you want to understand the properties. You want to understand the properties you want to understand the properties of this soil. So what you're going to do, there will be some standard penetrating equipments, so you apply some force and you measure how much it has got penetrated. You increase the force and again you check the penetration value. So again and again this value is taken down. So what you are doing, so you are measuring soil resistance, or you can say resistance to penetration. You can call it as a resistance to penetration. So resistance to penetration can also be linked to its engineering property. So what are engineering property? Such as density index, bearing capacity, etc. These can be correlated to its resistance to penetration. That is what it is here explained. The sounding methods, the generally it consists of measuring the resistance of soil with depth by means of some penetrometer. Penetrometer is one device which is going inside the ground. Okay, under static load or dynamic load. Static means the load value is constant. Dynamic load means the load value is changes with respect to time. That is static and dynamic. The resistance to penetration is empirically correlated to its engineering properties. Means what? The whatever resistance value is nothing but what? Some value which has taken to the this load and this penetration. Okay, so here whatever resistance is made by the soil, no, to get to penetration, for the penetration of this one, that is correlated to its engineering properties such as its density index, bearing capacity, and the common test we use for standard penetration test and cone penetration test. Just you remember the name of the test. So this is with respect to subsurface soundings. In this next method, that is geophysical methods. Okay, these are called as geophysical methods. These methods are used when the depth of exploration is very large and when more speed of investigation is required. When you want to have a pile foundation for a bridge, that time you can go for this geophysical method. Or when the speed of investigation is very highly required, means you want it to be completed before a shorter time, so that time you go for geophysical methods. So in this major categories are gravitational method, magnetic method, seismic refraction method and electrical resistivity method. Seismic refraction method and electrical resistivity method. Okay, so we will go this one. Seismic refraction, what is there? Okay, in this seismic refraction method, the shock waves are created into the soil. If there is a soil and in some portion you hit with something, hammer or something like that, to a metal strike, this will generate what? Shock waves. Okay, and how it is generated, that is here it is written. Shock waves are generated by exploding small charge in the soil or by striking a plate on the soil with the hammer. Means what? Here a small explosion can be possible. You can make a small explosion so that it will create shock waves, or by hitting a steel plate with some hammer, that is also create some that is also create some shock waves. First step is what in this method? In the seismic refraction method, shock waves are created. How? By exploding a small charge or by hitting with the this one. Okay, plate with the hammer. Now, if you see this diagram, that is what here it is clearly explained. Okay, this is one typical seismic refraction method. Here what is happening? These are starting point. This is the first point. What is written here? Explosive charge. Means what? At this point you are creating the shock waves. You are creating the shock waves. Okay, now this is the ground level. This is ground level. Okay, this is continuous ground level. Here some what is that? Some receiving things are kept. So what they will receive? So the receiving pieces are kept 1, 2, 3. These are called as detectors. Now these detectors will receive shock waves generated from this point. Anyhow, waves will pass through the soil. No? So here it will generate, it will move like this, it will move like this, it will move like this. So in any possible direction, so like this it is going to move. Okay, okay, like this they are going to move, and at some point they are going to reach again from the wherever there some interface is there. From there they will hit and reflect back. From there they will hit and reflect back. So like that, whenever there is a density change in the soil, there is a density change in the soil, they will get refraction. They will get refraction and they will move towards the surface, and these are signals are detected by called as detectors. These are called as detectors. So first is what? Explosive charge, shock point. Second portions are detectors. Now there are different strata. There may be different data in the soil. So strata 1, strata 2, strata 3. What is that Z1, Z2? Its depth. So strata 1 is of Z1 depth, maybe 10 centimeter, maybe 15 centimeter, like that. So Z2 is a different value, Z3 is a different value. So why these stratas are made? Strata means what? A different property layer. Different property layer. So here properties are changed, here properties are also changed. These are not same. If these are same, then we call it as total one strata only. So by calling stratas 1, strata 2 means properties changed here, and here soil properties are different. So like that they are going to change. Now these will record the shock waves generated from here, and these will also record the time at which the shock waves have been detected from this phone, from this phone. Okay, so like this they will record the time of travel. They will record the time of travel of these shock waves from this first point to these detecting points, first, second, like this. They will record the shock waves time travel in seconds or minutes. Okay, that is possible in seconds. Now you know the distance and you know the time, so you can get the velocity. No, can velocity. So v is equal to d by t. Okay, t is obtained from the recording detectors. D is nothing but the distance between the first shocking point and the detector's location. First shocking points and detector's location, like that you can get the distance. So you finally get what? Velocity. So from velocity you can correlate to its engineering properties. Engineering properties. So there may be some standard graphs. If velocity is like this much, from 5 5 kilometer to 10 kilometer per second, then the engineering properties like cohesiveness, density may be this. So like that you may have. So whenever there is a change in the density, you will get what? Refracted rays. You will get what? Refracted. What is this at the top? There is a seismograph. Seismograph is nothing but measuring the all the times, all the values. So that is one instrument. So it will measure all the things. Okay. This diagram is clear. Okay. Okay, now, so this is called as seismic refraction methods. Seismic refraction method. So now we'll go to the points wise. What is written there? So we have completed this one now. So there is a shock waves generated. Okay, how it is generated? By exploding a small charge or by striking a plate with some hammer. Second point, what? The radiating shock waves are picked up. The radiating shock waves are picked up by the vibration detector. So that is what the detectors were there now. So 1, 2, 3, like that. Okay, this is the shock point. This is first point. This is the detector's point. Okay. Now seismometer or geophones. So these are also called as seismometers or geophones. Geo, not Reliance Geo. These are called as geophones. Okay. So now what you are measuring? Time of travel. You get what? Time of travel of shock waves. So number of geophones are arranged. Number of geophones are arranged there. Okay. In next, if the underlying layer is denser, so you will get what? If underlying layer is denser, so obviously the refraction will take place. Do you agree with this point or not? If it is very dense compared to this layer, so obviously the shock waves will get refracted. Okay, so that is what it is explained here. So denser means another point is also there. They will travel much faster. The waves will travel much faster. So different kinds of materials such as gravel, clay have different characteristics. Seismic velocities will be calculated and are identified with distance and time graphs. So we have seen what velocity is finally calculated. So distance between the geophones and time of travel. So you got these things, you get velocity. So what is explained here is what is explained here is different kinds of materials. Maybe gravel have some different velocity, clay has some different velocity. So these seismic velocities are correlated to its engineering properties. So engineering property identification is nothing but site exploration. Yes or no? We are studying the site exploration. That means what? We are going to study the soil property. How we are studying in this method? Seismic refraction method. We are studying the velocity of shock waves generated. That is what we call it as seismic. Okay, seismic velocities. So this is the seismic refraction method. Okay. This is the next diagram for electrical resistivity method. The name of the method is electrical resistivity method. So three terms are there. So electricity means what? There should be one battery or source of supply, and to make a current pass, so you should have potential difference. So that is why we are writing it as potentiometer. So for electricity you have some battery, that is written here. You have some potential difference setup, so potentiometer. Also you need to measure the resistance to flow of current. Simple word, resistance to flow of current. This is the four major components. Now ammeter is there. Ammeter measures what? Current. Yes or no? Ammeter measures the current. So current symbol is I. In physics you have learned, I think. Okay. Potential difference is nothing but V. Sometimes you can also measure the resistance. So another term will come, ohms. No, ohm. Okay, ohm is nothing but resistivity property. Ohm is nothing but resistivity method. What are these small points? These are called as electrodes. Electrodes are nothing but which allow the current to pass through. What they are doing, they are setting up the potential difference here. Potential difference such that current will come and pass through this electrode and it will go to here. It will go to here. Okay, so like this they are making a current to pass through the electrode and move through soil. That is very important. That is very important. Now at the end you are finally finding what? Resistance, and resistance is correlated to engineering property. That's all. The main theme of this experiment is to find out the resistance of the soil for current passing, and later on it is correlated to its engineering property. That is nothing but our site exploration. That's all. Okay, so we'll go to the next what is that? Theory portion. You can see here. Electrical resistivity method. It is based on the measurement and recording of changes in the mean resistivity. Means what? For time, some time resistance may be one value, maybe another value. Like that, it is measuring the and recording the resistivity of the soil. Resistivity of what? To pass through the current. Okay. Each soil has different resistivity. That is understandable. On what parameters it is depending? It is depending upon the water content, compaction, composition. If water content is changed, or compaction value is changed, or composition itself is changed, so all of these things impact what? Its resistivity for the flow of current. So now for saturated silt, resistance is very less. Loose dry gravel or solid rock, resistance is high. Okay, like that. For saturated silt, the resistance is low. For solid rock or loose dry gravel, the resistance is very high. So both way it is possible. Okay, so like that it depends upon water content, compaction, composition. Now, here how it is conducted. The test is conducted by driving four metal electrodes into the ground along the straight line. Means what? One electrode, two electrode, three, four. Four electrodes are driven into the ground. Now, a direct voltage is applied between the two outer electrodes. That means this is the two outer electrode. There may be some source of supply. Okay, so that voltage is applied here on the two outer electrodes. Now the potential drop may happen here. Potential drop may be happening. So where it is measured? Here one potentiometer is there. Potentiometer is there, that is seen in the diagram. Now these two electrodes which are inside, so these two are called as outside electrodes, 1 and 4, 2 and 3 are called as inner electrodes, 2 and 3 called inner electrodes. So you are applying voltage outside electrodes, voltage on outside electrode, you are measuring the potential drop for what? Inside electrodes, okay, for inside electrodes. Now at the end, the generally here the resistivity of the soil is measured using this formula. Okay, so resistance ohm centimeter is computed using 2 pi d ei, 2 pi d e divided by. So what is 2 pi are constant, d is what? Distance between the electrodes in centimeter. So 1 and 2, 2 and 3, 3 and 4. Generally these distance are kept same or constant. Okay, now E is what? A potential drop between the inner electrodes. So there is a potential drop what we have seen. So it is called as potential drop, capital E. I is what? Current flowing between the outer electrode. So we have seen here one ammeter was there. Ammeter was there. So it measures the flow of current. Flow of current. So that is written in I. So at the end, this ohm or resistivity of soil is linked to its engineering properties of the soil. Engineering properties of the soil. So engineering properties of soil studying is nothing but site exploration. It's called as site exploration. Okay. So generally here depth of exploration is proportional to electrode spacing. That is one thing. Okay. There is one more thing. Here in basically you are studying what? Electrodes, emitter, potentiometer. You apply the potential difference to the outer electrodes, you measure the resistivity in the inner electrodes. Okay. Okay, next we will continue it in the next class.